Heat. Part 1. Let us take a look at what is heat and temperature. So, what is heat? Heat is a form of energy. It can be transmitted by flowing from a hot object to a cooler object. Heat is not matter. This is because heat doesn't occupy space and has no mass. Properties of heat. Firstly, heat can be felt, but cannot be seen. Secondly, heat always travels from a region of higher temperature to a region of lower temperature till equilibrium is reached. This means that both objects in contact have the same temperature. Heat energy stored. The amount of heat energy stored in an object depends on its temperature and mass. A 200 milliliters beaker of water at 70 degrees Celsius has more heat energy than the same beaker of water at 30 degrees Celsius. 200 grams of water at 30 degrees Celsius has more heat energy than 100 grams of water at 30 degrees Celsius. Sources of heat. Examples of natural sources of heat includes the sun, volcanoes, and geysers. Examples of man-made sources of heat include starting a fire, rubbing two objects together, and electricity. Do note that most light sources are also sources of heat too. Usefulness of heat. Heat keeps living things warm. Heat is used to sterilize equipment to kill bacteria. Heat is needed to maintain the water cycle. Heat given out by the sun allows for evaporation of water to form clouds. Heat allows cooking to take place, and it is also used to dry clothes. Now, let's take a look at temperature. Definition of temperature. It is a measure of the degree of hotness or coldness of an object. The unit for temperature is degrees Celsius. Temperature is measured using a thermometer, or using a data logger with temperature or heat sensors. Some common features of a thermometer. Narrow glass tube. It allows a small amount of expansion of mercury, which is detected by the rise in the mercury column. Bulb. The large surface area of the bulb allows for quick heat transfer to warm and expand the mercury column. Alcohol or mercury. Mercury expands well in the presence of heat, but alcohol is preferred as it is cheaper and safer than mercury, which is toxic. Part 2. We will explore what are conductors of heat, what is expansion and contraction. Conductors of heat. Good conductors of heat have a faster rate of heat transfer. For example, metals are good conductor of heat. Pure conductors of heat have a slower rate of heat transfer. For example, wood and plastic are pure conductors of heat. Objects gaining heat from the environment. A good conductor gains heat faster and its temperature increases faster. A poor conductor gains heat slower, and its temperature increases slower. For example, a metal cup from the fridge takes 2 minutes for its temperature to be at room temperature of 28 degrees Celsius, while a glass cup from the same fridge takes 4 minutes for its temperature to be at 28 degrees Celsius, since glass is a poor conductor of heat as compared to metal. Objects losing heat to the environment. A good conductor loses heat faster, and its temperature decreases faster. A poor conductor loses heat slower, and its temperature decreases slower. For example, a metal cup with a boiling hot water at 100 degrees Celsius takes 2 minutes for its temperature to return to room temperature of 28 degrees Celsius, while a glass cup with the same hot water takes 4 minutes for its temperature to return to 28 degrees Celsius, since glass is a poor conductor of heat as compared to metal.